Welcome to this deep dive.
Great to be here.
Today we're tackling really a massive question, arguably the question, what is the mind?
It's a big one.
Yeah. We've been immersing ourselves in this fascinating source you shared. It's a really comprehensive report. Pulls together ideas from, well, all over the place.
Right, things like artificial life, neuroscience, cognitive architectures.
Exactly. And it really pushes you to think differently, doesn't it? It suggests the mind isn't just some static computer.
No, not at all. More like something alive, dynamic.
Agentic, maybe?
Agentic, yes, and possibly even conscious.
So our goal here is to, well, unpack all that. Go beyond just summarizing.
Right. We want to pull out the core nuggets, The most important insights that help us understand this integrated adaptive system the report proposes is operating inside your head right now.
Okay, let's dive in then.
Okay.
Forget the brain just processing data like a calculator. This report suggests something much more organic.
More organic, yes, or lifelike. It draws heavily from principles in artificial life, or a life.
A life, right?
And the core idea there is that the mind, much like living things, isn't just passively receiving input.
It's doing something.
It's actively maintaining itself, adapting, evolving over time.
Ah, okay. Like a kind of dynamic ecosystem, constantly changing and learning.
Precisely. The report really highlights how general intelligence itself seems rooted in that capacity for adaptation.
So it's about being able to flexibly create these temporary mental structures, representations.
Yes,
Yeah.
on the fly.
That's
to
right.
tackle new problems you've never encountered before, think of it as the ability to just constantly learn and grow.
And it's not like there's some central CEO figure telling everything what to do, right? The report mentions self-organization.
Yes, that's a key A-life principle, showing up in how we think about cognition. Complex behaviors, complex functions.
Even consciousness.
Potentially, yeah. They can emerge from the local interactions of simpler parts like neurons without needing a central command dictating every single step. It sort of builds itself, in a way.
So less like a meticulously engineered machine.
Right.
And more like, I don't know, a city growing organically. Or maybe a colony of ants where complex stuff happens from simple individual rules.
That's a good analogy. And interacting with the environment, that feedback loop, is absolutely crucial.
Mm-hmm.
And this self-organization, it leads naturally to the concept of autonomy.
Okay.
The mind, as the control system for you as an agent, has this capacity for self-regulation, for acting independently. It senses the world and acts on it over time, not just reactively.
But proactively.
Okay.
Pursuing its own goals.
Exactly.
Proactively.
This focus on the mind as an agent makes so much sense. It's not just waiting for instructions. It has its own agenda.
Mm-hmm.
The report calls this motivated control, right?
Mm-hmm.
How the mind coordinates your behavior towards things that are valuable, integrating your goals,
Right.
deciding what's important right now.
And linking that agentic view back to self-organization, there's this fascinating idea about intrinsic motivation.
If the mind is constantly trying to organize itself, build coherent models, reduce uncertainty about the world, that inherent drive itself could be seen as a form of internal motivation.
So it's not just about external rewards.
Right. It fuels exploration and learning, even when there's nothing obvious to gain externally.
So the very act of making sense of things is internally rewarding for this kind of mind. Okay, so that's the sort of lifelike perspective.
Yeah.
What about how it operates, moment to moment? The report talks a lot about dynamics.
It does, yeah. It looks at the mind through the lens of dynamical systems theory, which basically emphasizes how complex nonlinear interactions between all the parts leads to flexible, adaptive behavior. It's not just a simple chain reaction.
Right. And here's where it gets really interesting for me, this idea of modestability. It's not a term you hear every day, but the report presents it as totally central to how the brain functions. How would you explain that simply?
Okay, think of it as a constant dynamic balance.
A balance between what?
Between different brain areas working really tightly together. That's integration and also maintaining their own distinct roles, segregation.
So they're collaborating, but also keeping their independence.
Exactly. It's like a flexible team.
Okay, so the brain isn't rigidly locked into one pattern, but it's also not just random noise.
Precisely. It's
Yeah.
in this state of Unstable attraction is one way to put it. The system doesn't get stuck in one fixed mode, but it doesn't jump around randomly either.
It settles briefly.
It briefly settles into certain patterns that are useful for whatever you're doing, but then it's ready to shift quickly to something new. And this allows it to explore this huge repertoire of possible mental states, possible transitions between them, which is crucial for adapting to new things, for flexible thinking.
That ability to sort of transiently visit different states without getting stuck,
Right.
that sounds essential for creativity, doesn't it? Being able to shift perspective.
Absolutely. And the report connects this dynamic balance to another really powerful idea: operating near self-organized criticality, or as it's sometimes called, the edge of chaos.
It's the sweet spot.
Exactly. It's this critical point between being too ordered and rigid and being too random and chaotic. The report suggests this is where the brain can process information most effectively.
So, like a system where small changes can lead to big effects, but not too big, not spiraling out of control.
Yes, that's a good way to think about it. At this critical point, the brain is highly sensitive to lots of different inputs. It has maximal dynamic range, technically speaking, and it's really efficient at transmitting information.
And things like neuronal avalanches fit in here.
Right, those bursts of activity that cascade in a sort of predictable but not too predictable way, they're seen as hallmarks of this critical state.
So operating at this edge of chaos sounds fundamental, not just for efficiency, but for higher level stuff like adaptive behavior, general intelligence.
It really appears so. This state is linked to higher fluid intelligence, a better ability to handle uncertainty, even things like more open-mindedness.
Wow.
And the report even hints that the complex, integrated dynamics right there at the edge of chaos could provide the necessary conditions for conscious experience itself.
So this isn't just some technical detail about brain mechanics.
No, it seems fundamental to the brain's power, its adaptability, and maybe even your awareness.
Okay, so we've got the lifelike nature, the constant dynamics. Now let's explore the blueprints. How might this dynamic system actually be organized? The report looks at cognitive architectures, different models of the mind structure.
Right, and a recurring theme you see across many of these different models is the idea of a cognitive cycle.
The cognitive cycle.
Yeah, it's like a fundamental loop. The system takes in information, makes sense of it, decides what's important, selects an action, carries it out, and then learns from the outcome.
Like a continuous loop of perceiving, understanding, attending, acting, and learning.
Exactly that. Some models, like Lato, which is biologically inspired, explicitly structure cognition around these overlapping cognitive cycles.
Okay.
Others, like ACTR or SOAR, they also operate through these iterative processes, whether they're driven by goals or maybe resolving internal conflicts.
Even Mechasapiens, the one aiming for synthetic consciousness.
Even that one incorporates cyclic phases in its design.
The fact that these really different architectures all seem to converge on this cyclical processing principle, it really emphasizes how important it must be.
It really does. It seems to be how an intelligent agent stays connected to a constantly changing world and, crucially, keeps learning from it.
So let's maybe quickly touch on what makes a couple of these unique, like Leda.
Sure. LADA, or Learning Intelligent Distribution Agent, really sees the mind as a control structure for an agent. Cognition emerges from these cycles. It uses various memory components and these little specialized mini-processors called codelets.
Codelets.
Yeah, to build representations and focus attention. And a crucial idea in LADA is that significant learning happens when information reaches what it calls a conscious broadcast in a central workspace.
Okay, so attention and some form of conscious access are like key gateways for learning in the LIDA model.
Right. Then you have ACTR, Adaptive Control of Thought Rational. That's a model very focused on human cognition.
Right, I've heard of that one.
It makes a strong distinction between knowing facts, declarative knowledge, and knowing how to do things, procedural knowledge, often represented as IF-then rules.
Okay.
And it models working memory not as some separate box, but as the currently active part of your long-term knowledge, often driven by whatever your current goal is.
Interesting. And SOAR, state, operator, and result. That sounds more problem-solving focused.
It is, very much so. Its core idea is that achieving a goal is like searching through a problem space, using specific actions or operators.
How does it decide what to do?
SOAR's decision cycle is about proposing, evaluating, and then applying these operators. A key feature is its ability to automatically create sub-goals when it gets stuck. It calls this an impasse.
Ah, okay, like breaking a problem down.
Exactly. And it learns by chunking, basically creating new rules based on how it solved those impasses, which helps it avoid getting stuck the same way again.
That sub-goaling and chunking. That sounds very much like how we humans figure out complex problems and build up skills over time.
It maps quite well, yes. And finally, you mentioned Mecha Sapiens. That offers a blueprint specifically aimed at creating machines capable of synthetic consciousness and, interestingly, intentional self-transformation.
What it calls lucidity.
Exactly, lucidity. This model is quite different. It talks about concepts like a fundamental core and an inception process, operating in distinct phases driven by needs.
And self-awareness in that model comes from building a predictive model of itself, a MEM model.
Yes, a dynamic, adaptive, internal model of itself and potentially others, which then influences its behavior. And the pursuit of lucidity is defined as the capacity for the system to intentionally transform itself by modifying its own internal processes.
Wow, it's fascinating how these architectures, from the sort of biologically inspired lady to the problem-solving focus of SOAR and the synthetic consciousness goal of Mecha Sapiens, they offer such different but maybe complementary views.
They really do. They show the multifaceted nature of the mind we're trying to understand. And taken together, they suggest a trend toward understanding the mind as increasingly complex and integrated.
Okay, so moving inward from those architectural blueprints, let's talk about the core processes. How your mind takes in sensory input and actually makes sense of it. The report makes it clear it's not a simple passive pipeline.
No, definitely not. It starts with perception and attention, which the report emphasizes is an active construction, not just receiving data passively.
Right. Your sensory organs turn physical energy into neural signals.
Which go to different brain areas for basic feature extraction lines, edges, colors, sounds.
And then,
In successive stages, these simpler features get combined into more complex representations, like seeing lines and curves combined to form shapes, and shapes combined to form objects.
and this builds on some inherent organizing principles, like the brain's built-in rules for grouping things.
Exactly, Gestalt principles and things like that. But crucially, it's a two-way street. You have bottom-up processing coming from the senses.
Interacting with top-down signals.
Yeah,
From your existing knowledge, your memories, what you expect to see.
precisely. Models like LIDA explicitly capture this interaction, categorizing input based on what's already in memory.
And given the absolute flood of sensory information coming in all the time, selective attention must be vital.
Absolutely. But the report points out it's more than just filtering out noise. It's an active process, maybe even an inferential process.
Inferential, how so?
Well, some models suggest attention works by modulating how much weight, how much importance you give to different signals, or even to errors in your predictions about those signals.
Based on what you care about.
Yeah.
Your goals.
Exactly. Based on what you care about, what you're trying to achieve, the current context, your goals are constantly influencing what your brain prioritizes from that incoming chaos.
And how does the brain actually do that?
Neurally, it involves structures that act like gates for information flow and also synchronized activity, like brainwaves, between different areas. And your prefrontal cortex provides that top-down guidance.
Boosting the relevant signals, suppressing distractions.
Exactly, all guided by your current task or goal.
This brings us right back to that motivated control idea we talked about. Your motivations directly shape what you pay attention to.
Right. The report mentions in the LIDE model, for instance, there are these specialized processes, the codelets again, constantly looking for anything salient or important that should grab attention and potentially become conscious.
So you're not just passively seeing what's out there. You're actively building what you perceive based on your brain's best guesses and your current priorities.
That's a great way to put it.
Which leads naturally to understanding and situation modeling, how you build coherent mental representations to make sense of your experience.
Right. This is where you construct these dynamic mental models of a situation, who's involved, what's happening, where, when, maybe even why it's happening.
And that involves pulling together the new information coming in with everything you already know.
Exactly. Integrating it with your long-term memory, your facts, your past experiences, your beliefs, using working memory as the kind of temporary workspace for it all.
How do models like LIDA handle this?
LIDA uses specific processes for this, building links, creating structures, even running little simulations in its workspace. It views understanding as this iterative process of finding the best fit for the incoming information, kind of like solving a puzzle.
And the report also discusses this through the lens of predictive coding, doesn't it?
Yes, the idea that the brain is constantly predicting what sensory input it expects to receive based on its internal models
And any mismatch, a prediction error.
is used to update those models. So anticipation prediction is a core part of understanding. You're always guessing what comes next.
The report highlights a specific brain region here, the angular gyrus, or AG, as being critical for this sense-making process.
Yes, the AG. It sits at this really crucial junction between sensory areas, language areas, and memory areas. It's like a hub for integrating information from all these different streams.
So it helps process meaning and language.
Yes, and it also seems to act as a temporary buffer, holding and manipulating diverse bits of information, helping you build those coherent situation models over time.
So the AG isn't just passively relaying information, it's actively binding things together, putting information into context.
Exactly, helping you move beyond just individual pieces of data to form these cohesive judgments about complex situations. And this active construction of meaning applies to everything external sensations, your own internal thoughts.
And all of this relies fundamentally on memory systems, right? The report emphasizes memory isn't just one thing.
No, it's multiple interacting systems for encoding information, storing it, and retrieving it.
So working memory, that's like your mental desk, the active workspace.
That's a good analogy. It's where you hold and manipulate information for current thinking, problem solving, understanding language. It has limited space, as we all know.
Tell me about it.
But you can get better at using it by chunking information together or developing skills the report calls long-term working memory.
Okay, long-term working memory, like experts having quick access to relevant knowledge.
Sort of, yes. And working memory is the crucial link between your active processing and your vast store of long-term memory.
Which includes specific events, episodic memory, and general facts semantic memory.
Right. Information moves back and forth, from working memory into long-term for storage, and from long-term back into working memory when you need to remember something or use it.
In models like ACTR, you said working memory is just the active part of long-term memory.
Yes, the part that's currently activated and relevant to your goal. Neurobiologically, the report links the prefrontal cortex to maintaining this temporary information, while other areas help decide what's important enough to bring into this active workspace.
What about the brain processes themselves? Encoding, storage, retrieval.
Okay, so encoding is transforming information into a format that can be stored. This involves changes in the connections between neurons, often guided by the hippocampus,
Storage is keeping it.
across different timescales, from brief sensory memory to working memory, and eventually stable long-term memory. The report even mentions a possible intermediate-term memory stage between temporary working memory and really stable LTM.
Interesting. And getting it back out, retrieval.
Retrieval is an active process. It's not like just pressing play on a recording. It's reconstructive, meaning it's influenced by cues, by the context you're in when you try to remember. Expertise, like those long-term working memory skills, involves building specialized structures in LTM that make retrieval much more efficient. The report mentions cue-based foraging, basically. Your brain searching through LTM based on hints or cues.
And consolidation, that's making memories stable, right? Often during sleep.
Yes, but the report highlights it's not just about making them stronger or more stable, it's also about re-representation.
Re-representation.
Yeah, memories get restructured, integrated with knowledge you already have. They often lose specific minute details but gain general principles. They become more abstract.
This re-representation sounds key. So memories aren't static snapshots. They're dynamically reshaped.
Exactly. Abstracting away details to build general knowledge, maybe even contributing to wisdom over time. And the angular gyrus, that hub we mentioned for binding information and creating meaning, seems perfectly suited for this kind of process.
And maintaining beliefs is also active work.
Yes, the report notes it's a constant effort to keep things coherent, updating based on those prediction errors we talked about. When something challenges a belief, that internal conflict drives adjustments.
So it's really a continuous cycle. Building, testing, and updating your internal model of the world based on experience and what you already know.
Precisely.
Okay, so building on these core processes, perceiving, understanding, remembering, we get to the higher order cognitive functions. Things like reasoning, problem solving, planning.
Right. And the report really sees these as emerging from the complex interplay of those more basic functions we just discussed. They're not totally separate modules.
So reasoning, drawing conclusions from evidence. Is it one general skill or are there different types?
The report suggests it might be one fundamental capacity used with different levels of rigor, or it might involve specific types, like causal reasoning, figuring out cause and effect.
Causal reasoning is pretty fundamental for building an accurate world model.
Absolutely. And reasoning, whatever type, relies heavily on what we call executive functions.
Like working memory to hold the pieces, attention control to stay focused.
Yes, and cognitive flexibility to switch approaches if one isn't working. The report links certain brain areas involved in handling conflict and suppressing those quick wrong answers directly to reasoning ability.
What about theories of how we reason?
The report touches on ideas like building mental simulations to reason things out, and also dual process theories.
The fast intuitive thinking versus the slower, more analytical thinking, System 1 and System 2.
Exactly, that interaction.
And cross-domain reasoning, like using analogies.
That's seen as crucial for creativity, applying principles from one area to a totally different one. Brain areas involved in reasoning are widespread, but the prefrontal cortex is critical again, especially for applying rules, resolving conflicts, and inductive reasoning.
So the report frames reasoning less like abstract logic in a vacuum.
And more like running internal simulations to test ideas and possibilities.
Okay, what about problem solving? Finding a path from A to B.
It starts with defining the problem space, mapping out the possibilities, often within a temporary mental model you build for the task.
And then you use strategies.
Right. Strategies like trying to reduce the difference between where you are now and your goal state, or that means-ends analysis we saw in the SOAR architecture.
Setting sub-goals to overcome obstacles.
Exactly. And sometimes solving a problem requires completely restructuring how you're thinking about it. That's what we often call insight, the aha moment.
And just like reasoning, problem-solving leans heavily on those executive functions, doesn't it?
Absolutely. Using working memory to juggle the pieces of the problem, inhibitory control to avoid going down dead ends, and flexibility to try different strategies when you get stuck.
The report links general intelligence, often called G, directly to this, right?
Yeah.
Executive functionability and problem-solving capacity.
Yes. EFs are like the conductors orchestrating the whole cognitive orchestra during problem solving.
Okay, and planning, figuring out sequences of actions.
Yeah. The report suggests viewing it as a hierarchical process, predicting the consequences of actions to reach desired goals, or, just as importantly, avoid future problems. Mentally simulating outcomes.
So breaking down big goals into smaller, manageable steps, which is strongly linked to higher general intelligence.
That's right. Individuals with higher G tend to be better at abstract thinking, seeing further ahead, building better mental models for planning, and they often invest more effort in the planning phase itself before acting.
And the prefrontal cortex is critical here too.
Definitely critical for planning. And the report references insights from AI, suggesting that sophisticated human planning, mediated by the PFC, likely involves exploring multiple potential plans in your head and refining them iteratively, much like advanced AI planning algorithms actually do.
This brings us back nicely to general intelligence, or G, and learning itself. Learning is how you acquire knowledge and skills.
And G is the broader capacity that seems to underpin this learning and adaptation across different domains.
The report emphasizes that brain learning isn't just about storing facts, is it? It's fundamentally about that re-representation idea again.
Exactly. Memories evolve. They go from specific instances to more general semantic knowledge, abstract rules, core principles. Brain structures involved in memory, like the hippocampus and interacting cortical areas, are key to extracting these generalizable insights from experience.
And the report gives a more technical definition of G.
Yeah, something like the ability to flexibly create and manipulate temporary mental representations on the fly to solve new problems effectively, often by breaking them down and integrating solutions iteratively.
And the neural basis seems to involve efficient mental segmentation, breaking things down, and integration, putting them back together.
Yes, and particularly the ability to update information rapidly in working memory. That seems highly correlated with standard IQ scores.
The report even suggests consciousness might play a role here, compressing information.
Right, potentially by creating these hierarchical representations and checking for inconsistencies, which leads to more abstract understanding over time.
And brain dynamics are strongly linked to G as well.
Very strongly. Higher G is associated with more stable transitions between different brain networks, more efficient overall network usage, specific connectivity patterns involving key hub neurons.
And operating closer to that edge of chaos state we discussed.
Exactly. G might even be partly a learned ability to optimally manage your cognitive resources, with those flexible dynamics at the edge of chaos providing the necessary substrate for it.
Okay, so orchestrating all of these processes, the perceiving, understanding, memory, reasoning, planning, we have executive functions and cognitive control.
Right, the conductors. And the prefrontal cortex is central to this orchestration. Different parts seem to handle different aspects.
Like cold control for working memory and planning versus hot control involving emotions and value judgments.
Exactly. And other areas, like the anterior cingulate cortex, are involved in detecting conflict or errors and signaling the need to adjust control. Task switching also involves specific networks.
So control is fundamentally about boosting the signals relevant to your goals and suppressing the distracting ones.
That's a core aspect, yes. The report touches on models describing how this control is managed. In the active inference framework, for example, control is seen as modulating the precision or the attention you pay to different signals, basically guiding your internal simulations towards desired outcomes.
The report also discusses something called semantic control. What's that?
Semantic control is your ability to flexibly manipulate meaning. Think about the word bank.
Money, place, or riverside.
Exactly. Your semantic control system helps you select the right meaning based on the context. It's not automatic, it requires control.
How does that work in the brain?
It seems to involve interaction between brain networks that process sensory information and these transmodal hubs that integrate meaning across different senses. But the report distinguishes a separate network specifically for semantic control.
Involving the prefrontal cortex again.
Yes, areas in the PFC that uses more domain general executive functions, managing your goals, guiding your search through possible meanings, resolving ambiguity to dynamically shape your understanding of the world moment by moment.
This leads naturally to metacognition, doesn't it? Thinking about your own thinking.
Exactly. It's like an internal supervisor monitoring and regulating your own cognitive processes.
So there's metacognitive monitoring, assessing your own understanding.
Right, which leads to subjective feelings like the feeling of rightness or FOR, that intuitive sense you get about whether an answer feels correct, often linked to that fast, intuitive System 1 thinking.
And then there's metacognitive control,
Which is adjusting your strategies based on that monitoring. For example, if you get a low FOR, a feeling that something's off, you might decide to slow down and think about it more carefully using System 2.
And metacognitive knowledge is just knowing about thinking in general.
Yeah, knowing about cognitive biases, effective learning strategies, things like that.
The report sees metacognition acting like a kind of value function for cognitive actions, helping you decide if it's worth putting in more mental effort.
That's a key idea. It helps you allocate your limited cognitive resources effectively.
And this ties directly into that dual process theory, System 1 and System 2.
It does. System 1 gives you quick impressions, heuristics, intuitions. System 2 allows for deliberate, slow, analytical reasoning and correction.
And metacognition mediates between them.
Exactly. That feeling of rightness from System 1 heavily influences whether you just trust that initial impression or whether you engage the more effortful System 2 to double-check or scrutinize it. Factors like how difficult the task feels or even your individual thinking style influence which system tends to take the lead.
What about intuition itself, linked to System 1? Is it just magic?
Not magic, no. The report suggests it's largely rapid pattern matching based on extensive experience. But one interesting idea proposed involves dynamically restructuring stable feedback loops in the brain.
Possibly linked to the brain operating at that edge of chaos state.
Potentially, yes, leading to these sudden aha moments, insights that arrive without conscious step-by-step logical deduction.
Okay, finally, the big one, consciousness, subjective awareness. The report tackles this too, proposing it's an emergent property.
Yes, an emergent property of complex integrated brain activity, not something added on top, but arising from the system's operation.
It's seen as multi-level, an integrated awareness of the environment, your internal states, your own processes.
Right. One key idea presented, the integrated world modeling theory, suggests consciousness is the experience of being an embodied agent navigating the world based on its integrated, constantly updated model of reality.
This model building is hierarchical, from basic neural stuff up to top-level control.
Yes, and the report suggests that from an algorithmic perspective, consciousness builds these hierarchical representations by constantly checking for inconsistencies, involving active inference and integrating information about your body, your physical self.
There's another perspective mentioned too, the attention schema theory.
Right. That proposes that our subjective feeling of awareness might actually be the brain's internal model of its own attention. This attention schema helps the brain control its own focus, predict the consequences of shifting attention, and even understand the attention of others. It's an attempt to bridge different theoretical approaches.
And the integrated world modeling theory tries to synthesize various ideas too, emphasizing the need for a coherent mental model of the world's space, time, causality for conscious access.
Exactly. Information integration alone isn't enough. It needs to be part of this meaningful world model. You need context.
What brain processes likely underpin this?
Well, the report mentions several candidates. Compressing information into more manageable, abstract representations, recurrent processing, where information flows back and forth between brain areas, binding different features of an experience together,
How does binding work?
potentially through neural connections that learn from prediction errors. Also, competition between different possible interpretations, the brain striving for internal coherence, global broadcasting of important information to many areas, and of course, that pervasive theme of predictive processing.
The Mecha Sapiens blueprint offered an engineering view aiming for lucidity,
Where self-awareness comes from that predictive metal.
and the EAPSI framework pointed to recursion, thinking about thinking.
Yes. ERE being the potential for recursion in a system, and Psi measuring the active engagement in recursive processing at any given moment. High levels of both might be the state we experience as consciousness, like crossing some kind of threshold into self-aware processing.
These diverse ideas, pulled from the material, they really highlight that consciousness probably isn't one single simple thing.
No, it seems deeply related to how information is structured, integrated, modeled, and ultimately experienced by the agent. The hierarchical nature of our understanding seems to mirror hierarchies in the brain and maybe even in the world itself.
At its heart, it seems consciousness is about constructing a coherent model of what matters now for you, the agent, solving the relevance problem.
And those dynamic properties of brain activity operating near the edge of chaos are seen as integral. That state isn't just efficient. It allows the rapid, flexible transitions between global states that seem necessary for conscious awareness to flicker and flow.
The report even suggests consciousness might originate from the learning process itself, specifically through learning by binding.
Yes, linking features of experience together, driven by those prediction errors. It's viewed as an iterative, algorithmic process building those hierarchical representations. The source explicitly connects this binding process, along with statistical learning and self-organization at the edge of chaos, to the predictive reshaping of our internal models that underlies conscious experience.
And a key function of consciousness, according to the report, is information compression.
That seems to be a major proposed function, yes. By creating these integrated, compressed representations of yourself in the world, it allows for much more efficient processing overall. It enables complex decision-making, facilitates planning for the future, and supports adaptive behavior, especially in novel situations. That compressed, integrated model is what allows you to act flexibly and navigate the world effectively.
So, as we've explored in this deep dive, based on the material you shared, the mind is, well, it's absolutely not a static, rigid information processor.
Not even close. It's a system in constant motion, always balancing between order and flexibility, operating right there on the edge of chaos to stay adaptive and efficient.
We've seen how different models and theories, from the lifelike principles and dynamical systems view to various cognitive architectures like Light-A cycles, SOAR's problem spaces, ACTR's memory model, and Mecha Sapiens' push towards synthetic consciousness. They offer these diverse, yet often overlapping, blueprints for understanding this incredibly complex, dynamic system inside us.
That's right. At its core, your mind is relentlessly active. It's constantly perceiving the world, deciding what to focus on, building mental models of situations, predicting what might happen next, learning from absolutely everything.
And consolidating memories not just as static facts, but transforming them into generalized principles, into richer, more abstract knowledge.
And those higher functions we talked about, reasoning, problem-solving, planning, they don't just happen in isolation. They emerge from the synergy, the working together of all these underlying processes.
All expertly orchestrated by your executive control system.
And shaped by your capacity to reflect on your own thinking, that metacognition leveraging both your fast intuitions and your slower, more careful analysis.
And then sitting atop all this complexity is consciousness itself, potentially arising as the subjective experience of being an agent with a coherent, integrated model of the world.
Or perhaps, as another theory suggests, it's the brain's own model of where its attention is focused, dynamically linked to that critical operating state.
This whole journey through the source material reveals that advanced intelligence, and this thing we call the mind, isn't just about having individual high-powered functions like good memory or fast processing.
No, it's about how they all work together, what the report calls cognitive synergy, and that remarkable ability to take seemingly unrelated pieces of knowledge and creatively connect them to make something new and useful out of them, making non-useful knowledge useful.
So here's something to really ponder based on everything we've unpacked from this material. If your mind is constantly learning, if it's actively constructing your reality through these dynamic predictive models, if it's operating in a metastable state that inherently allows for continuous exploration and adaptation, and if it's building this internal narrative of both yourself and the world, what does that imply about your own capacity for intentional self-transformation? The very lucidity that this report posits as a potential, maybe even desirable goal for artificial minds. What does it mean for you to potentially intentionally guide your own internal architecture and dynamics?